Hi, in this tutorial I want to show you how to import Python modules defined in one package in ROS, import them in other packages in ROS. So this is a very common problem when you work with Python in ROS, and I had this problem myself, and I wanted to share this with the world so any people that have the same problem don't have to face hours of searching for the solution. So to show you how this is done with an example, I'm going to use this infrastructure called ROS Development Studio created by the construct. So if you go here to theconstructsim.com and you click here in ROS Devel Studio, you can sign up for free and use it for free, and you just have to do an account. I've already done one, and you'll get something like this. Here you can store, you have all the simulations. I have loads of them already. So to create your own, just start here and select this gazebo, in this case in gazebo 7, and you create your own simulation. So you have to put a name, for example test, I don't know, and it will create one for you. In this case I've already prepared one for you so that it's easier and faster. So to launch this simulation you just have to click play and then select the main launch that you want to launch. By default, when you create a simulation, it will generate this main launch, which is will launch an empty simulation. So we wait until it's launched. Okay, it's ready. So basically what you have here is a Python notebook, a web shell, the simulation already running. You just have to click play, and then you have an IDE with all your user, all the folders and all the packages that you created. So this is like working in a local machine with ROS. Is exactly the same. So all the things that you learn here, that I show you here, are exactly the same in a local computer. So here you have the IDE, and I've already created two packages, which are the examples that we are going to use. I've created this common tools package and this my robot package. My robot package would be your main package, the one that imports Python modules. And this one, the common tools, is the one that has those Python modules. So to create this packages, I've only done so you have to go to Catkin workspace, source, and here do a Catkin create package, then the name of the package, let's say test package, I don't know, and then the dependencies. In this case I only use ROSPy, in this case, in my case, and this will generate you, there you have it, this package, but we're not going to use that one, just to show you. And what you generate, what you get when you generate the Catkin create package is just a source folder, CMake list, and a package XML. That's it. So what do you have to do? So create this common tools package with the name you want. Just remember, bear in mind the name, and you'll get something like this. You won't have this, and you won't have this also. So the first thing you have to do is create this folder called Common Tools Package inside the source directory. This is very important. Once you have it, generate this init.py, which is an empty file. So let's do it here in the test. So we go here to the test, we go to the source, we create a folder that has to have the same name as the package, in this case test package. Okay, and then inside it you generate an empty file called like this, init.py. That's what it's an empty file that Python uses to find this folder, basically. So once you have it, you generate your modules inside this folder, the common tools package in this case. And the test package would be here inside, where you have the init.py. Yeah. So in this case, I generated this Python file, which you can generate through the IDE, like anything. I mean, it's exactly the same as in a local computer. So you create this Python file. In this case, I generated this clock subscriber class, which is a subscriber of the clock topic. Very simple. And you can call it and get the time. Very, very dumb. Okay, once you have it, there's some extra steps. So in order that the whole ROS ecosystem can find your modules, you have to add this setup.py. Again, you generate it by just right-clicking here, for example, or through the web shell, as you wish, and has to have this name. So setup.py. Inside it, you have to basically copy this code. This is a code that is given by ROS documentation, so it's not made by me. The only thing that you have to change is the package. In this case, in the test, should be this one. And then what you're saying is, inside this package, go to the source directory, which is this one, and inside it, you'll find all this. This will make, in the time of compilation, it will compile it in a way that ROS can find all this stuff. So the final step is you have to go to the CMake list txt, and as you can see, I've erased all the extra stuff that you don't need. Okay, there we go. So essentially what we're doing is, this is by default, you'll have it already. So if we go here, you'll have something like this. You see, find package. Let's put the highlight so that it's easier. There you have it. So it is exactly the same. But then you have to uncomment this line. So if you can see here, it's here already, but it's commented. So you just have to uncomment this line. Once you have it, so we can uncomment it, no problem. Then once you have it, that's it. It's the only thing that you have to do. This will be already there, and this also will be already there. That's it. So the final step is, so we have to go to our Catkin workspace and compile Catkin make. Yep. There we go. We do a source. And this is ready to find your modules that you defined here. In this case, our beloved clock subscriber. So now it's a time of going to your ROS package that uses this class. So you go here, I created this class, this Python module, which imports from the package common tools package, you see, clock subscriber. So essentially what it's doing, it's getting this and accessing this module here through this mumbo jumbo that we did here. And then you import the class. So very, very simple. And then you do it, you use the code. Then what I created here is, let's do it a bit simple. So what I did here is a launch file that launches this node. So it's launching from this package, this Python. So effectively, we are using this Python script. As you can see, I've created this scripts folder because I think it's better that if it's not Python code that you want to import, it's better that it's just scripts that execute stuff. It's highly recommendable. I highly recommend that you put them in a script, while the stuff that you want to import, then put it inside the source with this folder structure. Yeah. So if we execute it, so we go here and ROS launch my clock call, and as you can see, it stopped. Why? Because now just hit play, the clock starts, and there you have it. So it just prints the time in intervals of 3 seconds. So 2 times, that's it. That's the code that I had here. If you want to see it. So essentially what I'm doing is getting the time. Just when I create this subscriber class, I get the time, then I wait for 3 seconds and then get it again. So nothing fancy. So as far as importing Python modules from other packages, that's it. But I want to show you also how to configure the CMake list so that you install the stuff, the scripts. This is also very useful if you want to install your packages inside your computer or already compiled so that they are faster, or you have to install them in a server or whatever you want. So let's put the highlights, which helps a bit. So this one is the CMake list of the My Robot package. As you can see, is slightly different from this one. This one, the only thing that we wanted is this Catkin Python setup. In this case, we don't use that one, but what we're doing is getting all the Python files from the scripts folder. And then we are installing them in the binary destination with the correct format. So what we're using is this line, catkin install Python. The programs, here we put all the list of the programs that we want. In this case is this one, Python scripts did. It's a list of all the Python scripts that we have. And the destination is the catkin package binary destination. Then we are installing also the launch folder so that when we install it, we have accessible the launch files, and we install them in the shared destination. That's it. In the case of the common tools package, as you can see, there is nothing. Why? So it won't install anything? No. It will install something, but it will install it in a Python format. You'll see. So we can go here, and instead of compiling normally, we install. Okay, it went really fast because I already compiled. So as you can see, there are loads of things that are made here, and I want to show you. So let me clean up this bit. So we have a build, a devel, and an install. The thing that interests us most is the install. So let's get inside. And you have two folders that are really important for the installation: share and lib. These folders will be installed in different paths. So if we do, let me see, ls opt ROS indigo in this case. So this is the system. So you'll have to install the share, the things that are stored in the share folder in the system, and the library in the library folder. Clear? So if we go back again to our local install folder, if we go inside the lib, for example, we are getting the following. We are getting this my robot package, we are getting this package config, and we're getting this Python 2.7. This Python 2.7 was generated because we wrote this line here. So in the CMake list of the common tools package, we stated this line. This line gets all this and puts it in a format as a Python module, a Python egg would be. Okay, so if we go back to here and we go to the Python 2.7 list packages. So there we have it. We have two. Why? Because we also wrote the line in the test one. So if we go to the test CMake list, if you remember, we uncomment this line. So it compiled and searched for all the things that you had in this folder, which you don't have anything here, but you have it. So if we do, for example, a test package, we don't have anything, only the init file. But as you can see, it generated the egg info file here and also the module folder. So inside the common, we have the init, but also we have the compiled versions and our code. So anything that uses Python now will be able to use your modules when you install them. Why? Because you'll install them inside the Python path. So anything that uses Python will be able, not only ROS, but anything that uses Python will be able to use your module. Yeah? This is one thing. If we go here, here, there we go. We have this package config, which is nothing very relevant. So this, you'll have to copy all this in the system also. It's package information for ROS. And then you have also this my robot package. Let's have a look. So this will be installed in the library folder in the system, which there you install all the things that are executable. So binaries and Python scripts. That's the way, the correct way of installing scripts and binaries. That's why it's in a different location than share. So let's go to share. In the share, we have all these packages. Okay, this, for example, if we go to the common, you see that you don't have anything. You don't have absolutely anything. But if we go to our my robot package, you'll see that you have the launch. Why? Why do we have the launch? Because we stated here in the CMake lists, let's have a look. So this one is the CMake list of my robot package. So we stated here that we wanted to install the launch directory folder. And this, when you install it, will be available. Yeah. So this is quite it. I hope this was useful. So if you want to learn more about ROS, I highly recommend you that you go to robotigniteacademy.com. Here you have many courses about a load of themes and topics that you can learn things like this and more. And if you want to practice, just use ROS Development Studio. You can execute any simulation that you want, not only empty simulations to practice code with ROS, but also other more interesting simulations like the Kabuki or whatever. Or for example, we have this shadow hand. For example, you'll have this simulations, complex simulations like this one, with your IDE, with your web shells, multiple web shells, and with Python notebooks that you can do some Python testing there. And that's quite it. Thank you very much and hope to see you soon.